So we're going to do a little bit more Chapter 8 review, now with added fiber and bits of Chapters 7 and 6. We're doing this because so many of you did not do well on your test, and math is cumulative, which means that it builds off of past math. And this chapter built off of 6 and 7, and all future math will build off of this. Here's our first problem. What we want to do is extrapolate the information and come up with an equation. So, Bullwinkle is 8 feet tall, which is twice as tall as Rocky. Now, we have to come up with an equation for this. So first of all, we have 3 things to an equation. Who can tell me what the 3 things we have to an equation are? Malia.
Operations, numbers, and a variable.
Oh, you named them all. Excellent. They've got operations, they've got a number, and they've got a variable. Expressions do not have an equal sign. Equations do have that equal sign. We mostly deal with equations because those are the ones that we're looking to solve. The only thing that we would deal with expressions is to figure out, like, just to write our word problem and discover it. So each equation needs to have an operation, addition, subtraction, multiplication, division, a number, and a variable. It can have more than one number. In fact, later equations technically have 2 variables. We would have a y equals something something x, but we are given the number for one of the variables, which makes that variable go away. We only ever deal with one variable problems. So looking back at this problem, we need to come up with a number, an operation, and a variable. First one's first, our number part is easy. Daniel, what's our number? 8. Number part's easy. That's supposed to be like a highlighter. Woo! 8. Now, what's our operation that's going on? What's the operation, Ben? He says either multiplication or division. So that's good. What clued you in on that? What clued him in on that, Romario?
Which is twice as tall as Rocky.
Perfect. We see that word twice. Now, and what is our variable? What is our unknown? Rocco. Yes. So that is our unknown. So we have that. 8 feet. What does this word is mean? We see this word is a lot in math. We see all of that. What does that mean? It's tricky. What does that mean? I'll give you a hint. Hannah is sitting in that chair. Or, Jaden is 11 years old. What does it mean, Hannah?
They're confirming that. Like, you definitely know that.
Yes, you're confirming. You know it. It is equal. It is equal. So, when we're doing this, here's the facts that we know. We know Bullwinkle is 8 feet tall. We do not know how tall Rocky is. And we know that Bullwinkle is twice as tall as Rocky. So Bullwinkle is twice the height of Rocky. Right? Do we see how we just wrote that problem out word for word? We did it just going by looking at our key phrases. And we already know, just like in our future ones where they give us a variable, we know that Bullwinkle is 8. We get 8 equals 2 times R. But how do I show my work and solve? Because I know we're super smart people and we can do it in our head, but how do we show our work and solve, Lucy? Perfect. Since we're multiplying by 2, we have to divide by 2 on each side. 2 divided by 2 turns into 1, and we are left with 1 R, or just R. And 8 divided by 2 is 4. So Rocky is 4 feet tall. Excellent. Now, we're going to be looking at those key term kind of things. We're looking at key terms to describe this equation. So we've got a variable D, we've got some numbers, 12 and 0.25, we've got an operation going on, and we got an equal sign because it's an equation. So, what operation is happening? What operation? Only Lucy can tell me. Go ahead. Division. D is being divided into 12 groups. Remember, this can be written as 1/12 times D, so it can technically be multiplication. It can be written as D divided by 12, or it can be written as D over 12. And remember, with our keep, change, flip, that's how we prove it. So we do keep, right? We do change, multiplication, flip, 1/12. Do we see how these two are the same? Yeah, with their Kentucky Chicken Fried, and we have all of this. So, what would be a nice key term to use here to describe it? I'm going to start with our variable. So we're going to say D, we're going to say D is, and what's a good term to use? I put some key terms there at the bottom. D is what? D is of, D is split, D is times, D is more. What do we do? What could we do? D is what? Anita? Yeah. It's split into what?
12.
Yes. It is split in 12, right? The total is 0.25. That's it. So when we had this word problem on our test that almost nobody got, all you needed to do was identify what kind of key terms there were, and then juice it up a little bit, make it fancy. You say 12 friends split the cost of a ticket, because this is our unknown. The ticket now costs 25 cents. How much was the original ticket? So, when we see this problem on this next page, we had D divided by 12 equals 0.25. Who can tell me how I solve this equation? Solve this equation. Michelle, what do we do? Perfect. We multiply 12 on each side. By the way, what does each side mean? When I say each side, Romario? Both sides of what? It's a great thing. Both sides of what, Rocco? Not both sides of the fraction. Both sides of what, Miles?
Right and left.
Both sides of what, Hannah? The equal sign. Both sides of the equal sign. As such, we're going to come back to that when we've got our less than, more than, less than or equal to, more than or equal to. I'm going to go over that because I saw a lot of mistakes happening there. We multiply both sides by 12. These two 12s go away because multiplying by 12, 12 over 1. We would get 12D over 12, or we could just cross cancel and boop, they go away. We get D equals 0.25 times 12. When I line this up, I'm just going to do a refresher. Whenever we do multiplication, we always just line them up on the right-hand side. And it doesn't matter where our decimal is. What does matter is how many times we move it. We move it over 1, 2. So in the end, we're going to move it back 1, 2. Now, all we got to do, we do our simple math. 5 times 2 is 10. 5 times 1 is 5. We make it a 6. Our magic 0. 2 times 2 is 4. 2 times 1 is 2. We get 300. But we need to move our decimal back, which means D is equal to 3. Excellent. That's how we solve it. So that's how we solve, and this is how we would write out our word problem using key terms. Remember these key terms, and if you can think of more key terms, because there are plenty, then use those key terms as well. Think about that. Split means divide. So we've seen this now. We've seen our ratio tables. These are basically the exact same thing as our ratio tables because they increase by a same amount every single time. They increase by the same amount. And if they don't, they're not following the rules. We can't graph them. It's not a linear line. So for this equation, when we do this, we always get y equals mx plus b. The increase here is 3, correct? Yes. That, whatever the increase is equal to our m. So the increase is always equal to our m. But Who can remind me what our B is? Who can remind me what B stands for? Miles?
The 0 something.
Yes, it has to do with 0 something, Oswaldo. It is the y-intercept. And what does it mean? Y-intercept is when, Fernando?
What is y when?
Yes. So B is our y-intercept. And essentially, the question's asking is, what is y when x equals 0? What is y when x equals 0? Now, let's look at this question. What is y when x equals 0? When x equals 0, it should take you 3 seconds to be able to tell me this answer. What is it, Elsie? 0.
Oh, I get it.
Here's when x is 0. There's y is 0. These are the same thing as ordered pairs. These are the exact same thing as ordered pairs. Here's an ordered pair. Here's an ordered pair. Here's an ordered pair. Exactly. So then what would our beautiful formula look like? What would our beautiful equation that we would write look like? We always know that it starts with a y equals. We're going to have something x. So let's see. I want to call on a new hand, but I have Hannah.
Y equals
3x. Are we done?
No. Yes.
Yes, because it would be plus 0. And does 0 matter here? No, we don't need to add a plus 0. If you need to remember it, sure, you can put that plus 0. You won't be wrong, but if I have 3 siblings plus 0 siblings, how many siblings do I have? 3 siblings plus 0 never matters. So my equation is 3x. Now, I can't always just keep increasing by 3. If I did this, it would be 6 and it would be 9. Does that make sense at all? No. It doesn't make sense at all because we're not increasing by 1 on the top anymore. We're not increasing by 1 on the top. This is when we do our plug and play. This is when we do our plug and play. So, for this, we have our equation. Y equals 3x. I want to solve when x is 5. When x is 5, all I do is plug it into x. So instead of having an x there, I'm going to put a 5. What is y then, Nathan?
15.
Perfect. 15. Similarly, now I'm going to plug in my 10, my other value. And what is y equal to, Matthew? Perfect. We get 30. So what we're noticing here is even though this is an increase by 9, it's because this is not an increase by 1. It's an increase by 4. So that doesn't make our equation 9x. Our equation has to be matched when we're only going up 1 by x. If we go up any more by x, so for example, if I had this and I had negative 1, 1, 3, 5, 7. Can I just get a straight out equation? No, because I'm increasing by 2. Even though it's stagnant, even though I'm continuously increasing by 2, I can only have it when I increase by 1. Things that we can do to remedy it is we would be able to divide by 2 whatever our y increase is, and that would be our new m, but that's not what we're doing right now for practice. Here's what we are going to do for practice. So we'll look at this one. Normally we're given our input, our x values, but sometimes we're given our output, our y values. So the first step is always to come up with an equation. What equation do we have here? We're going to have a y equals something x plus or minus something. Whether or not it's a 1 and 0, in which case we're just left with y equals x. Whether or not it's 3 and 1,000, we'll figure out what it is. We might not be able to fill out our whole equation just yet. But let's look at it. What can I fill out? What do I know? What do I know, Lucy? Oops, hold on. Lucy called me out. I did make a mistake. That was my bad. So now I fix. Hold on, I fix. So Lucy, now what were you going to say?
Since you're increasing by 2, you know the y equals x2 plus.
Perfect. So y equals 2x. Great. But we don't know if there's an intercept yet because I don't know what it is when it's 0. So now I have to check it. We plug in what the book called our position number, but we can just plug in any x value we have. So I've got y equals, and then I've got 2, and what's the x value I know? What x value have I been given? Elsie? -1. And I want my y to equal what? In this case, what do I want my y to equal?
0.
So what would the ordered pair be for when x is -1? When x is -1, what is y equal to? When x is -1, what is y equal to? Gore. 3. Exactly. -1, 3. Now let's check this out. 3 equals 2 times -1. Let's check that. 3 equals, and what is 2 times -1, Tobias? It is -2. Is 3 equal to -2?
No.
No, it is not. But what can I do? And remember, I'm allowed to do something here. I'm allowed to add or subtract. I'm allowed to add or subtract something to make it equal. What can I add or subtract to make it equal, Malia? 5. So I'm going to add 5. That is how I complete my equation. So my new equation is y equals 2x plus 5. And that's how we solve it. Y equals 2x plus 5. So in this case, the way we would go about solving it is the exact same thing that we were doing. We're going to plug in all of our y values. So on this side, we've got our y equals 2x plus 5. And I'm going to fill in all of my y values. 5, because I have a 5. 7, because I have a 7. I'm going to make it spaced out more. 7, we got a 9, and we got an 11. So I want you guys to use the formula and solve for me. Because this is y equals when y is 5, when y is 7, when y is 9, and when y is 11. So each problem is going to still have that 2x plus 5. 2x plus 5, because the only thing that we changed is the y. 2x plus 5 and 2x plus 5. Let's do the first one together. I want to solve this first one together. What are we doing actually? What is the term called? What do we want to do? Gore. We are doing reverse Pemdas, and for what purpose, Rocco?
To find the expression.
Very, very close. Not find the expression. What is it, Lucy? We already know the y value. We know our y is 5, 7, 9, 11. We're trying to find our x value, Elsie. So we are isolating that x. We want to get it down to an x equals. And no, it does not matter what side it's on. Typically, I like to put it on this side, but it does not matter. So let's do that first one. How do I solve? Actually, we're going to do this one right here. How do I solve? We're doing that reverse PEMDAS. So what's my first step, Jaden? Here's where we had some confusion. Whenever you're trying to get rid of something, you can only do the inverse operation. So the operation happening here is 2x, 2 times x. I can't get rid of it without dividing. The operation that's happening here is plus 5. I can't get rid of it without subtracting. So I'm going to subtract 5 from each side. 5 minus 5 goes away. 9 minus 5, we get 4 equals 2x. Now what do I do? I'm going to get 4 equals 2x. How do I solve that one? Jaden, what do I do? Gloria, what do I do?
Divide by 2.
Exactly. I divide by 2 on each side because that is 2 times x, and I want to get x alone. 2 divided by 2 is 1. We don't write that in front of it. 4 divided by 2 is 2. So we get our x equals 2. When it's 9, x is 2. I want you to do it with these last 3. 5, 7, 11 for our y values. 5, 7, 11. So if we look at these, I'm going to show you. What is the first step for this one? What's that first step? What is the first step for this problem right here? That 11 equals 2x plus 5. First step. Rocco. We are doing reverse PEMDAS. So what's the first step? Not the multiplication. That's not reverse PEMDAS. Malia. Subtract 5 from each side. Hey, wasn't that the step that we did for the other one? Because it's the same equation. For all of these, we are going to do a minus 5 on each side. In all cases, that 5 goes away. Now, 11 minus 5, we get 6 equals. 7 minus 5, we get 2 equals. 5 minus 5. What's 5 minus 5? 0. We get 0 equals. We have 0 equals 2x, 2 equals 2x, and 6 equals 2x. Now we do the same step we did for that other one. We are going to divide them both by 2. So I'm going to divide this side by 2. I divide this side by 2. 2 divided by 2 turns into 1. 6 divided by 2 turns into 3. So my x value for when it's 11 is 3. Here, when it's 7, 2 divided by 2 on each side, I get x equals 1. What about when it's 5, you guys? What about when it's 5? When y is 5, what is our x? Miles? 0. Our x is 0. And hey, that makes sense because this value right here is the value when x equals 0. Here's a quick refresher because all of you did poorly at this. A negative times or divided by a negative is a what? A negative times or divided by a negative is what? Melanie. So it is positive. For example, if I had negative 1 and I divided it by negative 2, those two negatives cancel out. The way that I like to remember it is a negative and a negative. I can just move that second negative sign and make it into a positive. What about a negative times or divided by a positive? What's that going to be, Lucy? Yeah, negative. And what about the next one? It's the exact same except I changed the order. Gore? Exactly. What I mean by the same is that negative times positive, positive times negative, whatever it is. Same exact thing. So those two are negatives. Now, here is the rule. The rule behind that is so the rule is if you have an even number of negatives, then your answer will be negative. If you have an odd number of negatives, your answer will be
Positive.
I've got it reversed. Nobody corrected me. I got it reversed.
Actually, it's wrong.
Look at that. I got it reversed. This is why we pay attention. An even number of negatives makes it a positive. An odd number of negatives makes it a negative. But that's only with multiplication and division. Only with multiplication and division. To refresh on this, I've got negative 1 times negative 3 times negative 7. Is this going to be a negative or a positive? Is it negative or positive? Nathan!
It is odd.
It is an odd number of negatives, which makes it negative, an odd number. What if I had negative 1 times 3 times negative 7? Now what is it going to be, Gore? Positive. What if I had -1 times -2 times -3 times -4 times -5. What is that one going to be? Daniel. No, it is going to be Gore. Negative, because we are following our odd number of negatives is negative. 1, 2, 3, 4. 5 is indeed an odd number, so we get our answer to be negative. Daniel asked a good question. Never mind, he asked a bad question. It's the number of terms that we're counting, whether or not it's even or odd. It's the number of terms. So if there's an even number of negative terms, then, see, here's one negative term, here's one negative term. If there's an even number of negative terms, then we get a positive value. That's why Daniel's question was a good question. Here we have an even number of terms, right? So we know back, we go even number of terms means it's going to be positive. But what did I do wrong here? Michelle? Yeah, the positives don't count. We don't care how many positive, how many negative. The only thing, or how many positives, we only care how many negative terms we have. We only care how many negative terms we have. So we have an odd number of negative, which means our answer is going to be negative. It doesn't matter how many positive terms I have. We only count the number of negative terms. Who can read me this problem out loud? Gore. Perfect. 20x minus 6 is less than or equal to 94. Great job. Now, what do I have to do here? Even though it's an inequality, I just treat it like an equation. So what do I do then, Lucy? Perfect. We're doing our reverse PEMDAS. We add 6. Here's where I saw a problem. Which is the other side? Here or here? Which one do I do? Which is my other side? We already know I have to do that. That goes away. But what's the other side? Which is our other side? I get the same hands this whole time. I'm going to call on Miles.
I've already answered.
Miles says the 20. Why is that incorrect, Rocco?
Because it's 94 because the less than or equal to separates it.
Yes, it's 94 because the less than or equal to separates it. That makes it the other side. So we do not add it to that 6. It also wouldn't matter because if we add it to our 6, we cannot make it 26x. We can't combine those because they are not like terms. So we add. We get 20x is less than or equal to 100. What is my next step and last step? What is my next step, Lucy? Perfect, because it's 20 times x. I'm going to divide by 20 on each side. That becomes a 1. It goes away, and I get x is less than or equal to 5. Excellent work. You guys don't do such a snazzy job. The last problem that we are going to look at for today's review is this problem. So hold on. We have our equation. We have part of our function table. Now, what I need to do is I plug in. All I do is I plug in each of these separately for my x value. But in 2 seconds, I want Jenna to tell me what the value is going to be right here. 1. Exactly, because when x is 0, that's what y is. That one should always take you about 2 seconds to do. That one should always take you about 2 seconds to do. The rest we plug in. -3 times -1. A negative times a negative is a positive. We get 3. 3 plus 1, because we still have that, is 4. And actually, let's look at this. How do I go from 4 to 1? How do I go from 4 to 1? Let's see. Gore. -3. Look at that, -3. So I'm going to do the same thing here because it's all by 1. -3. -3. What's 1 minus 3, Hannah? -2. What's -2 minus 3, Fernando? -5. You see how long it took me to complete that? There's several ways we can complete it. So I want you guys keep practicing and come up with problems that you need help with. That's what we will do tomorrow.